we are going to study velocity time graph. That is where all these motion problems that we have been solving, we can put it graphically and solve the problem. We can solve it graphically. If we make a plot a graph of displacement, distance against time, in such a, if we plot a graph of distance against time, that is S against time, if the vehicle leaves from rest, that means where the time is 0, it moves. If it accelerates, it goes up, accelerates up to it. If it goes up, and now guess, and if it goes up, that means the velocity, if it's moving at a uniform velocity, that if you see this, the gradient of this becomes the velocity. That's the gradient of this graph. But if we plot a graph of the velocity against time, if it accelerates from 0, from rest, it goes up. When it gets to a given velocity and decides to stop or accelerating and continue that velocity becomes the same. That is, at this velocity, it becomes the same. And the graph responds as shown, that the velocity is the same. So that's why the graph continues. If the vehicle decides to reduce velocity and starts coming to rest, you see the graph goes and they come back to this time almost at the 0 velocity, where at the 0 velocity where it now stops. It gives you this graph. So every graph, velocity time graph, responds to the question. The way you just follow the question and create the graph. We're going to do some now one by one. If we start to do them, let's look at the first one. It says a vehicle moves with a uniform velocity. It moves with a uniform velocity. A vehicle moves with a uniform velocity. He said the value of the uniform velocity is a uniform velocity of 20 meters per second. 20 meters per second. A vehicle moves with a uniform velocity. So this is velocity, this is time. So this is 0. So it moves with a uniform. A vehicle moves with a uniform velocity of, so it started from here, because it didn't say it started from rest. It said that it moved with a uniform velocity. Look at it. That means this line, as that is straight, shows that the velocity didn't change. It's in the same direction, uniform velocity. And it said, the question says, the vehicle moves with a uniform velocity of 20 for 6 seconds. So if here is about 6 seconds, 6 seconds. So it goes to this point that the vehicle moves with a uniform velocity and gets to that point. When it now gets to point 6 and then retards to rest. So from this point now, it comes back to rest. That's what the question is saying. So if it comes back to rest, that means the velocity starts reducing. Look at it, it starts reducing. It starts reducing. The velocity was 20, so now it's coming down. The velocity, it comes down to rest in the next 12 seconds. So it goes down. The next 12 seconds. This is, okay, 6 seconds. Let's assume that this is 12. So the next 12 seconds, that means 6 and 12, that is 18 seconds. So you see how the graph looks like. The vehicle started at 20 meters per second velocity. It continued. It didn't change velocity. So that's why it's a straight line, a straight horizontal line, because it didn't change. And now get to 6 seconds. It now starts decelerating, starts reducing velocity, starts decelerating because it's going to stop. And he did that in the next 12 seconds. And that next 12 seconds, if you add it to 6, that will give you 18 seconds. So the vehicle stops. Now, let's see what the question says. The question says, with a constant retardation, draw a velocity time graph of the motion. We have just drawn it on the board. He said again, calculate the retardation and the distance traveled by the vehicle. Simple. He said we should calculate the retardation. The retardation is the velocity divided by time, though it is negative. Velocity here, velocity is 20 meters per second. Time is 12. Look at the period of retardation. From here to here, that's the 12. So velocity, to calculate retardation, the retardation, A minus A is equal to the velocity, which is 20, over the time, which is 12 in this case. Look at it from here to here, 12 seconds. That was used to retard. So that gave 1.89 meters per second. That is minus 1.89 meters per second squared. That is the retardation. That is the retardation. Minus 1.89, just this 20 divided by the time, which is 12. Now the next question says, calculate the distance traveled by the vehicle. Distance traveled by the vehicle is simple. The area of the graph. The area of this graph will give you the distance traveled, just the area of this graph. And what is the area? This graph is a trapezium. It's a trapezium. We can say from here to here is 6. 6 plus the total, which is 18, times the height, 20, divided by 2. Simple. That's the area of this trapezium. Or, if you don't want to do it like that, you do, this is a rectangle, then this is a triangle. If you do the two, you get the same answer. The area of the trapezium, if you do the two, you get the same answer. 6, the area of a trapezium, the sum of the opposite sides, the sum of the opposite times the height over 2. That's all. So, which gives me 240 meters. If you don't want to do like that, you can say the area of this rectangle, which is 20 times 6. 20 times 6. Then the area of the triangle, which is 12 times 20 over 2. The same thing, that is 20 times 6, 120. 20 times 6, area of a rectangle. Then the area of this triangle is 20 times 12 over 2. That's 20, that's also 120 again. 120 plus 120, 240. So, anyhow you want to do it, is the area of this shape, which is the area of the trapezium, or the area of this triangle plus the area of this this rectangle plus the area of this triangle. Anyone you do will give you the total distance traveled by the vehicle, the area of the graph. So let me say the question now again. A vehicle moves with a uniform velocity of 20 meters per second. A vehicle moves with a uniform velocity of 20 meters per second for 6 seconds, and then retards is decelerating, retards to rest in the next 12 seconds with a constant retardation. Draw a velocity time graph of this motion and calculate the retardation and the distance traveled by the vehicle. That's what is on the board. We got the distance traveled by the vehicle, we got the retardation. Thank you very much.